Okay, so in the last video, I talked about the calibration of the magnetic field inside of the twin leaf, but magnetic field is maybe the trickiest thing to calibrate, but it's for sure not the only thing that we need to calibrate inside of the twin leaf and the incubators that we're gonna use for the experiments. So another very important thing is to keep track of all the environmental conditions to make sure we have a sample that is inside of a magnetic field and a control that has very similar environmental conditions with respect to the sample, and the only thing that changes basically between the two populations of the experiment is the magnetic field value. So to do that, here's a little schematic that I made. We're gonna have two different sensors, and one of the sensors is gonna keep track of temperature and humidity, and another one is going to keep track at the light. So you can see that temperature and humidity and LUTs, which is a light sensor. And basically the idea is to have two sets of these, and one is gonna be inside of the twin leaf, so the tiny hypomagnetic chamber, and one is gonna be used to measure simultaneously the control. The idea is that we want to have a system that keeps track of temperature, humidity, and light simultaneously in two different conditions. One is the twin leaf, one is the control, right? So we're gonna use that as a system to calibrate the environmental conditions that we have inside of the experiment. I took some sensors that you can see here, and this is the sensor for the temperature and humidity, and this other guy is a sensor for light. And basically I made two copies of the same thing, and this little holder I just 3D printed in order to have those two holes. I can use those to screw it down on the twin leaf so that it stays nice and stable in position inside of the twin leaf. And then I have an Arduino, so a microcontroller, and I'm gonna use these basically to read out from the sensors. And in order to connect these sensors to the Arduino, I need another piece, which is the multiplexer. And basically this allows to connect multiple sensors which have the same address to a single board, so that I don't need two different Arduinos for the two sets of sensors. And so I made this scheme mostly for me to figure out the wiring, and as you can see, I made a bunch of custom-made wires. I built these yesterday, and they are black, green, red, and blue. And so I used basically the same coloring to go over this scheme so that I know how to connect them to which pins of the sensors, the multiplexer, and the Arduino everywhere goes. And the idea is that these sensors have a I2C connection, and so I have these SCL and SDA channels that will go into the multiplexer, and there are multiple inputs for the SC and SD in the multiplexer, and basically the multiplexer will read out sequentially all of those, and so you can have a pretty much simultaneous, there's no such thing as simultaneous in physics, but we can say that pretty much at the same time we can read out the temperature, humidity, and light in two different environments using the multiplexer and connecting that to the Arduino. And yeah, so if you need more explanations about this whole scheme, I can certainly do that, write a comment down below, but the idea is that the Arduino will supply power through this black cable to the sensors and the multiplexer as well. There's going to be everything connected to the ground through the Arduino. And again, these communication channels are these SCL and SDA, which are split through the multiplexer and then go and communicate with the Arduino. And then, of course, the Arduino will be connected to a laptop through a USB cable. And I'll be able to use the Arduino interface to read out the sensors. And I'm going to use some Python code to basically store the values inside of a CSV file and then plot it and basically have all the data of temperature, humidity, and light be stored and available for anyone to go take a look. It's going to be online, the code is going to be online, and so as soon as I actually write it down, it's going to be available. So one thing that I actually forgot to mention is that we will not, unfortunately, be able to have real-time readings from these sensors because there is current and things going on electrically when these sensors are in the twin leaf especially, and so these are going to produce an electromagnetic field. And so in order to make sure that we actually reduce the magnetic field as much as possible, we cannot have any electronics inside of the twin leaf, and we cannot have any magnetic material. And I'm pretty sure there's going to be something that is lightly magnetic in the sensors. And so we will need to do a nice calibration when I get to Maryland, basically for maybe a few days, to make sure that the two environments are really comparable. But then we're going to have to trust those calibrations and try to keep everything the same, because you just cannot have any electronics inside. As you can see here, these are the sensors that are connected. There's a bunch of wire because these will go inside of the environments, and all these parts will stay sort of close to the laptop. And so, yeah, this is the final sort of situation. Not the cleanest one, not the cleanest setup, but gets the job done. And you see I have here the code. It's a Python code that is reading through serial connection the values that are read by the Arduino. And so yeah, basically this guy is getting data every 10 seconds. And here you can see it's basically plotting the temperature over time, the humidity, and the light. And those are the two different environments. We get the blue and the sort of orange curve there for the two different environments, and there's a slight difference, which is very, very tiny in temperature and humidity, which, I mean, could be real or could be just due to the sensors being slightly different and wired with different wires and so on. But yeah, so this is the setup, and I have been testing it here, and I'll leave it running overnight to see if everything runs smoothly for a long period of time. But other than that, I'll take all of this with me to Maryland, and we'll do a proper calibration when we put actually the equipment in the final place where we are going to run the experiments. So yeah, just a quick video here, but basically this is a pretty homemade DIY sort of solution for keeping track nicely of temperature, humidity, and light. And this whole setup is super cheap. The most expensive thing for sure is the Arduino, which is probably around $20 or so. And so this whole thing is you can do for $50 or less. And yeah, if you're interested, our Notion notebook will probably have a step-by-step guide on how to actually do this sort of setup. So if for any reason you want to keep track of temperature, humidity, and light in a bunch of environments, like in a bunch of rooms in your house, and you don't mind having cables lying around, then you can just go take a look and build some yourself. But yeah, if you need help with any of that, let us know in the comments, and we'll make sure to reply to all your comments.